I think we can start, right? So 10 minutes passed. So so today we are going to talk about this multi-factor authentication. Okay. But before that, as usual, just a few words about the course. Okay. Yes. This is the schedule, the updated schedule. Okay. So we are here today. So we will do a little bit of theory and then, as usual, experimenting with the code. Okay, and you will do this coding part next week, last lab number 14. Okay, tomorrow there will be lab number 13, which is about authentication, username and password and so on. Okay, and then we have a lecture here on Thursday. Okay, so last, let's say, considerations about last topic of the course, again, security and so on. I will be there for 1 hour and a half. My colleague will be there for the rest of the 1 hour and a half of the lecture. You will review the last lab, so the one about authentication. And in case you have questions and so on, you are welcome to ask him. Okay. And then we will publish the text of the first exam. We are drafting it, and so by the end of the week it will be ready, probably on Friday, okay? Not just Monday. Monday's holiday, okay? And so you will see the text of the first exam. So just for those of you who want to take the exam on the 23rd of June, okay? I think it's the 23rd of June. There are two esami polito. There are two dates, right? So for June, 1 June and 1 July. So 23rd of June, okay, and the other one 7th of July, okay? And then there will be one in September, of course, and one in January. January, February, we don't know yet, okay? And this is the deadline, okay? Actually, not really. I mean, the deadline is the evening before, okay? So will be the 22nd at midnight, okay? For submitting the solution in case you want to take the exam on the first occasion, that is the 23rd, okay? And there will be another text for the second exam, okay, on the 7th of July, to be submitted on the 6th of July, midnight, okay? And so basically in these 2 dates, I mean, I'm not sure if we are able to already do oral examinations of your submissions, because I mean, there are at the moment I think like 50 people booked for the first exam, okay, and some less for the second, and we will see how things develop. But in general, you know, with 50 people, we cannot really do oral examination in 1 day, okay? So first we need to have a few hours at least to collect all the submissions and make them ready for testing. And we will update you with the schedule of the oral exam a bit later in the course, okay? Actually after the course, because we can do this basically just 2-3 days before the submission, just, you know, assuming that everybody that wants to take the exam has enrolled in the exam, okay? And so we will remind you about this. So just try to not to be enrolled in the exam if you don't want to take the exam, so it helps us planning the exam a little bit better, okay? So there are instructions for the exam already published. Actually, they were published at the beginning of the course. So if you go to the usual, you know, home page, you see exam, okay? And exam, you already found all the rest, common instructions. This was available at the end, at the beginning of the course. Most frequent errors, I mean, just a little bit updated recently. Since it's very long, I mean, that's a very quick checklist, but I encourage you to read through all the document, the whole document, okay? I mean, just for you, for helping you, okay? It's not really, nothing is really needed, but of course, if you know in advance, maybe you can avoid you know, common errors. And there is this submission instructions, we will use GitHub Classroom for submission. Basically means that you just need to have a GitHub account, okay? Any account is fine. We don't really care, because when you enroll for the exam, we will provide you a link on this GitHub Classroom, which is a separate organization from GitHub. Okay, so you get this link, and at the first access, you need to attach your GitHub username to your name. Okay, there will be a list of names. Okay, everybody who is enrolled in this course has its own name there. In case you have problems or you don't find your name, just write me an email, write me on Telegram somewhere, okay? And we'll try to sort out the issue. It's probably, sometimes people cannot really find themselves just for basic reason. Like, I mean, they are sorted by the ID number, student ID number, okay? But I mean, if you are enrolled in this exam, you have this course in the Portale della Didattica, so in the web portal, I mean, you should be here, okay? Just downloaded the list, I mean, a couple of days ago, okay? So don't press skip the step, because the skip the step means, I mean, you're submitting something which is not attached to anybody's name, okay? In case you do, write me an email, tell me something, we'll fix the situation. This is to be done only once, okay? Only for your first exam, hopefully the only one, okay? So you pass it and you get 30 plus, okay? But in case you don't pass the first exam, or maybe you see that, you know, you are not able to prepare the submission and so on, and you want to take a second exam and so on, this procedure is already been done, and you can accept the second assignment, third assignment with the new links we will provide, without associating your name anymore, because it's already associated. I mean, your GitHub account is associated to your name just once, okay? The first time you do this operation. If you want to take the exam later, you don't have to do it right now, okay? And you cannot deassociate your GitHub account with your name, okay? So just be careful, select the correct name, okay? In case you make a mistake, again, send me an email, and we as teachers can, you know, handle this situation. We can disassociate names and stuff. Okay? Then you will accept the assignment, and a repository will be created for you. You don't have to work on the GitHub or with commits and so on. You just have to do one thing. I mean, a single commit that is the final solution you want to submit, and tag it with a tag which is named, what's the name? Final, okay? This is important because we need to distinguish those who just, you know, accepted the assignment, cloned the repository, try to work a little bit, and then just realize, well, I cannot make it on time. I will do the second exam, the third exam, and so on, okay? So if there is something but it's not tagged, we assume that you don't want to submit the solution for this final exam, okay, for the exam. Okay, and so just don't forget to tag it, okay? And it should be pretty clear. It worked very well since 5 years, okay? And not just this course last year, but even the previous one. So we hope there will be not so many problems, okay? In case you are in doubt, I mean, we have a Telegram chat, and we have system of communicating, emails and so on. Just write an email, or, you know, just try not to write an email for everything. And I mean, just because you are, you know, if everybody writes something, I mean, you are more than 200 enrolled in this course. Of course, we cannot be as much responsive as, you know, as in case just a few of you ask for help or clarification and so on. And try to read them, these instructions, I mean, not at the last minute, okay? Let's say before the end of the call. So in case you have any doubt, you can ask easily to me or my colleague what you didn't understand, okay? So take your time to and read, you know, all these instructions and all the documents that have been published, and, you know, try to I mean, ask for, in case you have doubts, and I hope everything goes in the best possible way for your exam. Okay? These are the exam rules. Actually, we didn't change them since the beginning of the course. Actually, these are the rules. Okay? Again, read them, and just, yeah, maybe it's time to say similarity checks will be run after the deadline using an automated software. Actually, I think I already said it in the beginning of the course, but now it's more clear. You know, you do this, the solution at home, okay, by yourself. And so we cannot really accept two solutions which are equal or almost equal. And we have a little tool that just do some checks. If things are equal, we will manually inspect them before saying anything. So don't be worried about the fact that there is a tool. It's just a tool because, you know, it's easier to compare. There are 100 submissions and there are like 5,000 checks to do, right? So a tool will do, and in case it signals something, we will check manually and decide what to do. Okay? But, you know, you're supposed to develop your solution yourself. Don't be afraid of using, you know, what we published during the course. It's normal, okay? Authentication, multi-factor authentication and stuff like that. We expect you to use what we provided as examples, okay? But of course, there will be something which is more peculiar to the solution. And in that case, how to structure the components, properties, and so on. Well, of course, everybody has its own idea. And it's normal, and it will be different from somebody else's idea, okay? We don't expect everything, every little detail be different, because with 100 submissions, something will be similar for sure. But, you know, everybody comes out with some proper ideas, own ideas, and that is normal, that is expected, and that is also what we can discuss during the oral examination, okay? Especially if these ideas deviates quite a lot from what we suggested during the course, okay? But I mean, don't be afraid of this if you do it yourself. I mean, we never encounter cases where people doing it by themselves had problems with this issue, okay? We encountered a couple of cases, but actually it was quite evident. I mean, almost the same file. I mean, really line by line, okay? And this cannot happen by chance. Okay. So I think it's more or less clear. And you have, remember, if you're curious, the last year's edition of the course is here, in particular the exams, okay? I hope you already took a look at this, okay? There are 4 texts that what we assigned last year. And, well, in a few days, there will be the first one for this year, okay? And the system is the same. We will ask you to leave some comments in the beginning in the text of the exam, which will be a Google Doc, okay? We will wait 2-3 days, and then we will start answering to these comments. At a certain time, we will freeze the text by fixing you know, the doubts that arose during, you know, this initial period of time when the text was published, because we are not perfect, okay? So we describe something we would like to have, but sometimes the description is not that clear, and many doubts can come out, okay? So it's normal to ask for clarifications, especially in the unfortunate case in which we were not clear enough. But, you know, after, let's say, 7 days, more or less, that we published the initial version of the text, we will fix the text, mark the modifications in red, so you know what has changed or what has not. But, I mean, not just to change the specification. We will not change the specification, but we will make things which are not so clear much clearer, okay? Depending on your feedback, okay? And the more people tries to solve the exam, let's say, the more doubts comes out, because everybody has different ideas, and, you know, it's normal, okay? So don't be afraid of the fact that you will see many comments and so on, but I mean, maybe just check if anybody else has already asked your question, okay? We will then, after let's say 7 days more or less, freeze the text so you cannot comment it anymore, and we will publish the comments with the corresponding answers in a separate document. Just because the Google Doc, when you disallow comments, doesn't show the comments anymore, unfortunately. Okay, but we will copy and paste and do this thing. We did it, you know, every year for all exams, and it was fine. Okay, so think a little bit about the exam, and maybe during the break or after this class ends, you can come and ask, and next time you can ask, and so on. Okay, so I think that's all in terms of communications at the start of the class. And so we can start talking about the last, say, big topic of this course, which is multi-factor authentication. Okay, maybe I shouldn't have shortened it on the first slide. Well, so can you give more than one evidence? Actually, multi-factor authentication stems from the fact that it's so difficult to protect access in web application nowadays, because there are so many attacks available, like cross-site scripting systems, or when you click on a link, so the cross-site request forgery. We will talk a little bit about this next lecture. I mean, just in terms of how the attack works, but it's basically clicking on a link coming from an attacker. I mean, you are tricked into clicking these links, and if you have an authenticated session, for instance, it's a problem. Okay, if they bring you to a page that looks like your bank and they ask you for username and password, you are tricked into thinking this is my bank's page, and they enter username and password. Okay, and then they collect it, they enter it on the true website, and they operate on your behalf. So this is not so good, right? And indeed, nowadays, most of the websites, I mean serious websites, where you do, let's say, serious things, important things, requires a multi-factor authentication. Often, multi means two, okay? So the traditional one, username and password, plus a second factor, okay? If you think in terms of Gmail, I hope everybody has used Gmail, but I mean, even the Politecnico website nowadays, I'm not sure about the student interface, but for the teacher interface, it asks for a second factor now. You know, you log in, username and password, and then you need to enter something else, like a code you received by email, an SMS code, a code generated by an app, or something like this, okay? A one-time code previously generated, and so on. So this is the second factor authentication. So in short, the user is required to present more than one type of evidence to authenticate on a system. If you have a look at the OWASP, which is a very good reference for security, as we already said during this course, it lists 4 types of factors that can be used. And if you want to have a second factor, the second factor should be different from the first one. Okay, otherwise it's useless in terms of security. So the password is in the first category, something you know, secret word, the password, pings or security questions, and so on. Other factors are something you have, okay, like tokens, certificates, smart cards, email, telephone number where you can receive SMS, phone calls, and so on. Okay, something you are, the fingerprints, stuff like that. Somewhere you are, okay, so, source IP address, location, physical location, and so on. It's something you do, like your behaviors. Okay, of course, I'm not saying that all these factors are the same in terms of usefulness for the authentication, that all are, have the same strength. Okay, some may be more suited for this task, some less, but this just gives us an idea about the different types of factors that exists. Okay? And so let's now focus on what is commonly done nowadays, the two-factor authentication. You log in on Gmail and they ask you username, password, and then a second factor. Okay? This is typically required at login, but sometimes this second factor or on another second factor can be required to perform and actually to authorize other sensitive actions. Okay, like when you want to change password, typically most of the websites implementing this second factor authentication, they ask you to enter to use a second factor, like enter a code received by email, read on your token, and so on. Okay, and other, I mean, in general, risky operations like, as usual, money transfer, permanent deletion of content. Okay, when it involves a lot of content and so on. Adding administrators and so on. I mean, the list can be long and depends quite a lot on the application. Okay, and actually we are focusing on this second factor. Okay, I mean, in this case, the two-factor authentication, which actually it's by far the best defense against the majority of password-related attacks. Okay, so you know that users with passwords are quite sloppy in managing it. They write it down on post-its. They don't encrypt it. They leave it visible somewhere. They use weak passwords. So if you have a second factor, you can increase the security of your system quite a lot. Okay, it says by far. It means quite a lot with respect to not having it or using other types of solutions. Okay. So, and as I say, the two factors must belong to different categories. So you cannot have a second secret because, again, it's something you know, same category that we said before. Okay? So it must be, it can be a value, a similar value to a password, a value similar to a password, but it must come from another factor. Okay? And that's the case that we will see here. Example, something you have that is the most common second factor used nowadays. It's a token, okay? It can be an hardware token, can be a software token. We will see the difference in a minute. So basically, it's a way to create something to be communicated to the server of our application that can only be generated from something you own, okay? You have, okay? So we will see this mechanism. Tokens that can generate basically a one-time password, so a string of characters, typically numbers, digits, can be both hardware tokens and software tokens. Okay, I'm not sure if you had some experience with hardware tokens. Typically, a few years ago, they came with your bank account. Okay, so you went to the bank, to the branch, and they gave you a little device. Typically, you attach it to your keys, or you keep it with you somewhere, and you press a button, and a random code appears. Okay, or maybe in others you enter a code and a code appears. These are hardware tokens. They are very, very secure because basically, since they are a separate element from any software device and other stuff you have, no connection to the internet and so on, they are almost impossible to compromise remotely. Okay, but of course they are very impractical. You need to have this token with you to get the code and enter this code. Okay, so if you forget the token at home, you need to go back home. I mean, the only place where you can generate the token is when you are in possession of the token. So, and also they can cost money. They're not just like an app or software that you download on a device, which is almost free, but it costs money to manufacture, to maintain. When you lose it, you need to replace them. You need to go to the bank again and ask for another one. They charge you, and I mean, it's not about the charge, but it's the fact that it costs money to produce and to maintain the infrastructure handling these tokens. So somebody must be available in case you lose it to give another one to you, and so on. Okay, so that's all the drawbacks of physical devices. Okay, so very good solution, but very unpractical. Okay, and so nowadays a lot of these tokens are software based. Okay, I think all of us already experimented with these software tokens. So you have an app, in short, that typically runs on a smartphone, on a mobile device, and can generate this code that can be used with your application. Okay. An example is the Google Authenticator, but I mean there are plenty of these apps available for any type of device. I mean Android devices, iOS devices, I mean basically all devices are supported. Typically smartphones, because it's a really powerful device, can have memory, can have secure memory inside, and you always have the smartphone with you, typically. Okay? And since they are so common, the software tokens has been also standardized, at least, let's say, the most common ones. Okay? So it's not just, a random algorithm thought or used by some random company somewhere and everybody using its own algorithm. Most of the times, all the systems use the same algorithm. So basically, these authenticator apps are somehow compatible between each other. Okay. Of course, you need to have something secret to make them work, and that's what we are going to talk about in a minute. Okay. So how do they work? I think you know, but let's review it. When a sensitive action needs to be performed, including login, you are required to enter a value, a code. Okay, the most common case is six digits. Okay, and the code changes over time. Okay, so the next time I require you the value, another value must be entered. Okay. So, I mean, the software tokens are very convenient. They are cheap. No problem in case. I mean, there's no device involved, so no logistic issues. Okay, so. I mean, if you lose your smartphone, you are more concerned about all the rest of the stuff you have on the smartphone than just this one. This one is important, but it's not the only thing you need to care about. Okay? You can easily change the token because, any website that uses this system has a way to establish a new token, software token. Okay, sometimes it involves, entering additional information, maybe a phone call, maybe, I don't know, visit a branch of the bank and so on. I don't know, depends on how they want to configure this procedure, but, simply you establish a new secret, and so basically you can have a new token. Okay. There are also disadvantages, of course, because, as I said before, an hardware device, independent of everything else, including internet, I would say especially internet, it's very, very difficult to compromise. The only thing that can happen is the battery is not, I mean, the level of the battery goes too low, and basically you need to replace it, okay? And typically, if you experience with these tokens, typically it takes a few years, okay, to replace it, but it's true that sometimes you have to replace it. But smartphones, unfortunately, there's a lot of software running on the smartphones, so you know, they can be compromised quite easily. They can connect to the internet. Again, we can try to fool the user into do actions which are unsafe and so on. Okay. If you are using this code required by a website that is accessed, but actually the same device, just browsing a website from the smartphone, and at a certain time it requires this additional token, just swap the application, search for the token, the value, you enter the value and so on. That's not the best possible, you know, situation in which you happen to be. Because, I mean, there's no real separation between the two factors. Okay, it's something you know, it's true, something you have, but actually that something you have is running on the same device that is running the website. So it risks to be compromised. Okay, sometimes because if the website tricks you into do something that let's say it's risky and expose some information it shouldn't be exposed, maybe you might have problems. Okay, they are able to duplicate this token, because I mean the issue of the token is that there is a secret that needs to kept a secret, right? And if this requirement is not satisfied, of course it becomes useless. Okay. And also there is the issue how to establish a common secret, because if you have an hardware device, the secret is already inserted before they give the device to you. Okay, before you give the device to the users, it's set up when you configure that token. Okay, and it never leaves the token again. When you have a software, at a certain time you need to configure this secret. You need to communicate this secret. And it's typically done during this activation phase, in which the server chooses a random value, pretty long value, so that it cannot be easily guessed, and send this secret to the client. And the client means, the client of the web application. And then the user has to take this software that implements the token and import the secret inside this software. Then the software will not show the secret again. It's true, but I mean that's this say a bit complex procedure to use when you set up the secret. Okay, the server will not show the secret anymore in the future to the client. Okay. And the client as well, I mean the token actually. The token will not show the secret anymore, will only generate codes based on this secret. Okay? That is why when you see the secret, which is typically shown in the form of QR code because it's easier to read it and to move it from the web client to the device. Okay? They tell you, well, I will show it only once, okay? I will not show it again, because otherwise it's useless, right? Because you need to establish the secret once and then only use these codes from which you cannot retrieve the original secret, okay? If you need to change the secret, you need a special procedure. You need something more secure, and you need to do something else. You cannot just say, well, I lost the token. I mean, you can say, but I mean, the procedure is not just, okay, authenticate with username and password, because it's useless, okay? Otherwise, everybody could say this. Okay, so just to make sure we understand each other in the rest of the course, we will only see a token, TOTP, for the login action. Okay, I told you it can be used for other operations, so to authorize other operations, but it's a more complex scenario. We will only see it used in the context of the login. Okay, it's an additional factor during authentication, as it is often implemented in many web applications. Okay, so it's not a way to authorize operations, it's a way to make the authentication more robust. Okay, good. So that's the whole procedure. That's the only drawing we see here in the slides. So in the beginning, in the initial setup, the server randomly generates some secret that is then saved on the server and is shown typically as a QR code. But it's also a string that you can read, that you can type, and so on. I mean, a bit long, but yeah, with some patience, you can type it. And since the token is almost always a smartphone, it has a camera, and so you scan the QR code, and basically you transfer the secret to the device, and the device saves the shared secret inside its memory. Okay. Sorry, and that is the initial setup. And then every time this code, this OTP code is requested, basically the server asks for this code. So there will be a page in which we can enter this code. And you need to take your device, and this shared secret is combined together with the time, current date and time, so a timestamp, with an hash function that creates a code. Okay, and this is the part that has been standardized for most of the tokens used nowadays. Okay, I mean, there is the publicly available tokens like the Google tokens and so on. Okay, and this code is shown on the display of the device, and the user basically copy it. Okay, and it writes the code in a form on the client. The code is sent to the server, and the server does the same operation because it has the same shared secret that was set up initially here in the initial phase. It combines it with the server time, a hash function, it gets a code. If the two codes are the same, okay, you can proceed and go and, in our case, proceed with the authentication operation. Okay, so you have an authenticated session that also has been checked against this second factor. Otherwise, you say, as when the password is not correct, well, the code is not correct, please enter another code, or, it depends on the application. You can proceed without the strong authentication, or if you require the second authentication, the user is blocked. It needs to enter a good code. Okay? Okay, so two things we need to notice here. First, you see the device time may not be exactly the same as the server time. It's true that nowadays most smartphones are, let's say, have a good synchronization with the exact date and time that is available over the whole world. But there might be a little bit of time difference, okay, a few seconds and so on. And indeed, this procedure that involves the hash function and so on has a little bit of tolerance that can be also configured on the server side about the difference in time for which the code has been generated. Okay? And the second thing we need to notice is that after setup, I already mentioned this, the secret never leaves the server again, nor it is shown to the user again. You set up the two-factor authentication, they give you the QR code, and they say, I will not show it to you again. Okay? Just to confirm you have set up everything correctly, enter the code that you see on the smartphone, on the token device. Okay? You enter it, and so the server, let's say, okay, it says, okay, good, I can keep it for me. I will never show this secret again to the user, to the client. Okay? And okay, so let's see how these things can be implemented in practice, as we did with Passport. Well, first, we need to create this secret key. It's very easy. I mean, random bytes, random vector of bytes, actually, a vector of random bytes. I wrote it a bit unclear. Like 32 bytes, or 256 bits. I mean, something which is, you know, quite long. Often this secret is converted into a convenient format for easier reading and storing. Okay, we're not so good at handling bytes. I mean, there's the exe format, I mean, not really convenient for users and so on, and also, you know, for many applications. And so just you know, there's just a conversion that happens. I mean, there's a library that does it, and I cited it because it's what has been done by the most common format for this time-based OTP values. Okay, and then this basically this conversion in base 32 format gives you a string. Okay, so the 26 letters of the alphabet plus some digits. And then for our purposes, we just simply store this string in the server database. And if we have to establish the secret, we also need to communicate it to the user. But I mean, this will not be required for our course, as we will see in a minute. Okay, and typically through a QR code, so you can scan it quite easily. Okay, with any authenticator application. These are the most common ones, but I mean, if you write TOTP authentication in Google Play Store or Apple, what's the name of the store, you know, you'll see plenty of apps. Okay, I mean, this is just some convenience code to create the QR code. I mean, just to show you. If you open Node and you run it, I mean, this is just for curiosity. We don't really need it for the course, but let's see. Node, okay. Paste. Yes, paste it. Ah, no, I need to install the. Sorry. I need to install this library, which is QR. Let me make some room test. PME init npm install QR code. I think that's QR code. That's the name of the package, right? I mean, just to show you how easy it is. No, QR code. Not code. And then you get something like this. Paste. Okay. You can simply copy and paste in the browser URL bar. Okay. It gives you the QR code. Okay. Actually, that's the only QR code we will use in this course, just for convenience. Okay. We know that every user, every system should have its own QR code and so on. It's actually the same as this one. Okay. Good. So as we didn't do anything for the user setup phase, so it's not required for the exam. Okay, it's not required in the lab. Well, no, actually in the lab, just for testing, it's required, you know, that you hash one password. Here it's even simpler. I mean, you just get a random string, and you create a QR code. But just, I mean, you can just copy and paste the string in many authenticator applications as well. Okay, so only for this course, the second generation part is not required. Just store the given string or the QR code. Okay, this one. That is also in the slides. Okay. This is just for our convenience, because if you come at the exam and you forgot to, generate a QR code, you have a string, like a secret string which has the same length as the screen and so on, we will lose 5 minutes to set up the secret in our application just to test it, okay? And 5 minutes for 100 students means we spend 1 more day doing oral exams, okay? So everybody is required to use the same secret, okay, for the exam. Also in the lab and so on. So you try to make it work in the lab and then it's done, okay? Note that this secret cannot be hashed. It's not like the password, okay? We need the secret in clear text to run the hash function that you saw before, okay? So here, you need the secret in clear text because the hash function needs to start from the clear text, because the hash function runs both on the device and on the server. Okay. So the only recommendation that we give here, but just for the future, not for the exam, just, as with any other information that must remain confidential, needs to be secured against attackers and so on, follow the standard guidelines that you can find around, like OWASP is a really good website and gives you really good guidelines, okay? Many systems, including cloud providers and so on, have ways of handling secret information of this kind. So just follow their guidelines, okay? They encrypt the information when it's not needed and so on. They only load the information when it's needed. You don't need, actually, you must not commit it in your code when you publish the code and so on, okay? So this guidelines says basically this, okay? But only for this course, only for simplicity, an additional column in the user table is fine, okay? So in the user table, we will have the salt and the hash for the password and the secret for the TOTP code in case it's needed, okay? Why I say in case it's needed? Because it might not be needed for some users, okay? I mean, only if we want all users to be authenticated using the OTP system, we need to have a secret for each of the user, okay? Which in our case will be the same, just for convenience, because we don't want to spend 5 minutes at the exam, playing with a mobile phone, trying to make the TOTP work, okay? Everybody uses the same secret, so it's already there. You have the secret there, and we just use that value, the value shown to do the authentication, and we are sure which is the value to be used without configuring anything. Okay, fine. We have the secret. So what does the client do? Actually, just a number to be entered somewhere, okay? So after the authentication, in our case, we are going to use it only for the authentication. So after the authentication, if it's required by the logic of the application, the user is asked to fill out a form, okay? Just one field, enter the code, okay? Just for our convenience, then, well, for convenience in general, store the fact that the user successfully performed the two-factor authentication in the application memory. This is about how to program the client, as we did for the password. We send username and password and get a response from the server. If the server says OK, we have this logged in status in the application, plus user information if needed. Again, here we can have logged in TOTP, okay, state in the application. So we know that certain actions that requires to be authenticated with TOTP can be enabled in the application. That's the same logic as the logged in. Okay? We disable or enable some features of the website. Okay? Good. So it's just a form. Nothing really new. You have the login form. You have the TOTP form. A controlled form component, a state that contains the value on change. It's not shown here. On change, set event, set TOTP code, event target value. Okay, just controlled form component. You can type stuff there, and then when you press the button, submit button, do the operation. There will be a call to the server. So typically in this API object, if you follow the pattern that we suggested, you go to the server at a special URL, send it the TOTP code, and then if everything is fine, so you get a 200 OK, you set this information in the memory of the client in a React state. Just again, for your convenience, logged in TOTP true instead of false. You start with false as for the authentication. Okay? For the libraries that we will use, you need to send an object that contains code as a property name and the value of the code as the value. Okay? And then we will decide an API route. Okay, I made it simple, login TOTP, but you can have anything. But I mean, try to keep things simple if possible. Okay, so client is finished because it's just a form. You need to send some information, get a response. Client is the easiest thing. As with the authentication, you have two fields, username and password, and a button, send, and you get a response. And then, what happens on the server? The server is a bit more complex. Server code is validated. So, you remember this diagram. So, this S function is computed to compute the TOTP code on the server side and check if it corresponds to the TOTP code received from the client. And if everything is okay, such condition is remembered in the session information on the server for later checking when needed. Like we remember the fact there is a session active, and we can associate information to that session active on the server, like the user ID that is logged in. We can also associate the information that the user performed the two-factor authentication. Okay? And that's the thing we will do. And if the code is not correct, as with the password, you just say, sorry, the code is not correct. You send back a generic response saying the code is not correct. Okay? Note that here, well, actually, as with the username and password as well, it depends on the application what to do when you get a negative response from the server. You can decide that the user can continue and some operations are not cannot be performed, okay? Because they require a higher security level. It's like with the password. If you don't authenticate, you only see the information which is publicly available to anybody who is not authenticated, okay? Like you enter on the Didattica Polito IT website, you see something, right? You don't need authentication to see that content. If you want to have something for you, you need to perform the authentication. And that's the same with the TOTP. If you need to have the second factor authentication to see some information, the server will give it to you only if you perform the second factor authentication. Okay? But it's up to you to decide if you want to show something else and allow the user to do other things in case the second factor authentication has not been performed or just failed. Okay? That is the same as not being performed. Okay? So the application decides what to do. Typically in the specifications, like for the exam, we will write that some operations requires to have the TOTP authentication performed correctly. Okay? just to test the TOTP. Okay, and then we have an endpoint on the server to which we send the code from the client. Like the login, actually we say the API session, post API, what was session current, right? And here we have a post API login TOTP. It's fine. Okay. Note that this API only works if a session has already been established. We don't want to have, we don't know what to do with the TOTP code if there is no session. There's no user associated with the request. We cannot even retrieve the correct secret because the secret is specific to the user. So this second factor authentication, of course, it's a second factor, it's not the first one. So we need to have authentication first. So this route is authenticated. Okay, so a session needs to be present before using it. Okay. Later, for other routes, for some routes, you will need to check on the server that the session is authenticated, of course, but also that TOTP has been performed. Don't forget this. It will come back again later. Okay? But such information, we said before, we store it on the session information memory on the server side when the login TOTP operation has been performed with success. Okay, so TOTP in Express. We have Express and we have Passport. Yeah, I should have said maybe plus Passport. Okay, and there is a library. I would say not so good, but good enough to experiment for us for TOTP in Passport. And this second library is just for encoding the string, so it's just a utility function. Okay. So we need to install and require them at the beginning of our code. Okay. The Passport TOTP gives us the TOTP strategy. Okay, remember the password works with strategies. We had the local strategy for the username and password. And this guy has implemented a TOTP strategy that basically is able to take a code and check against some information available in the server. It means the time plus the secret. Okay, and it works as shown here. Okay, so just copy pasting here, nothing to invent. I mean, you need only to find a place where you store the secret in the database, and you're able to retrieve it. Okay, like if you have a column in the database named secret, and when you get the information from the database, you retrieve the user information, you map this secret column to the secret field in the user, you get it here as quite easily. Okay, the user is the user object. That is the one that we configured during the last lectures, or during the authentication. When we configured the Passport authentication, the local strategy, we had the serialize and deserialize. We decided what to store in this user object. We give some recommendation with the examples that we published. Just add a new property. Okay, good. So it's quite easy to use, and the rest is done automatically. So the check, the hash, and so on is done automatically by this strategy, which is actually a library with some code. Okay, just be careful that if you store the information in the user object, you shouldn't give back the secret to the client. We say that once established, the secret never leaves the server. It's really, really wrong to return it to the client. Okay, we will not pass a solution with this error, with this mistake. Okay, instead, what you should tell the client about the user is the fact that, for instance, this user is allowed to do the TOTP authentication. Okay, so the second factor authentication, because the client doesn't know in principle if it should do the second factor authentication or not, especially if we have two different kinds of users. We say, well, all users need to do that. I mean, we don't really need this field, but point is, we might have the situation in which some users can do it, some users not, okay? We need to communicate this information to the client so that the client behaves correctly, okay? And also, the client has no way to know if the user has already performed the TOTP or not in the current session. You remember that last week we implemented the authentication. At a certain point we also said, well, you load the application. In the beginning you can go and ask the server if a session is already established, because you have the cookie goes to the server knows if it corresponds to an active session, it gives you back information about the user that is currently logged in. It's very convenient, not really required, but very convenient, and most of the applications implement this behavior. And so this is an additional information that can be sent back from the server to the client, okay? So that the user, the client knows that the user also performed the second factor authentication. Now, this is a property of the authenticated session, so it's fine to say this information to the client, okay? Because it's just a way to establish a stronger authenticated session, okay? So it's a property of the session. It's not like authorizing operation. This is a different story, which unfortunately we will not have time to cover in this course. Okay, and so just be careful that when you authenticate the user with the username and password, or when you get the information about the currently logged in user, don't send back the user information, okay, as it is, because it contains this secret. Remove it and instead add this information in yellow, okay, which is more convenient and also needed sometimes by the client application. And so just define a function. That's probably the best way not to forget about this, okay? Okay, fine. And then you're free to implement the login TOTP route on the server. Just passport authenticate TOTP, okay? It expects the code in body code, so in this object code equal to something. And in case of success, actually just store the information in the session. That's the way in which we recommend to store it. Rec session method TOTP, okay, is a string. Actually, we didn't see it because we didn't need it, but the local strategy of passport just stores information in the method field of session. It just stores plain. Just if you're curious, if you want to print it before doing the TOTP, you will see plain. That is basically, the local strategy. But here we change it to remember the fact that this session is authenticated with a second factor. And then you're free to respond anything you like to the client, like with the login. Okay. There's really nothing we should respond back here because the user is already known to the client. It's up to you to decide what to put here. Okay. Could be empty, could be an empty object, could be an empty list, depending on what you want. Okay, so just the two, let's say, warnings. So that's the issue of synchronization. You will remember the time was involved. Actually, this library has a default, I think, of 5 or 6 calls back and forth in the past and in the future. So basically, if the code that you sent matches like 12 codes, a window of 12 codes that moves on as while the time passes, basically it says okay. Otherwise, it says the code is wrong. Okay, so one point to remember. And the second point, a little bit more tricky. Actually, the implementation we are using, this passport TOTP, unfortunately, can accept the same TOTP more than once if it's still in this window, like 10, 12 codes window, okay? So actually the OTP part of TOTP is not really one time, okay, which is a bit unfortunate. And but at the moment I didn't find any better library. I mean, we are a bit restricted on the server side. I would say for sure this stuff is not production ready, okay, because if you really want an actual TOTP, after you send a code from the client to the server, you validate the code, you shouldn't accept that code and all the codes before that one in time, okay? So in this way, it's actually a one-time password. It means you need to wait for the next code and enter the next code, which cannot be predicted by the past, okay? Otherwise, this opens, allows you to perform many attacks, like replay attacks and so on, you know, sending again the code and so on, okay? But I mean, this is a choice we had to make in this course. I mean, we decided to stay with the Node, means JavaScript on the server side for convenience, because we already know the language. We don't have to learn a new language and so on. But let's say better implementation on the server side should reject codes which has already been used. Okay, we could have implemented additional code, you know, to keep a list, or you know, to understand what's the point in time and this code appears and not to go back and so on. But we had to, we should have modified the library and so on. And unfortunately, I couldn't find better libraries at the moment. Okay, maybe in the future things can improve, but that's the situation at the moment. And so, of course, it's fine for the exam. Everything we show as good practice in the lecture is fine, perfectly fine for the exam. Just be aware of this fact that we are basically testing technologies and try to understand technologies, especially on the client side. And just be aware of the limitations that we have, because we have to use some software, you know, in the end to make things work. Okay. Storing information in React, you get an answer from this route on the server, 200 or 401. So, okay or not authorized. And this information is typically stored in a state in React, as we said before. Okay? And can be retrieved with other APIs like the get user info that you might want to run at mount time of app, as we said last week, for the authentication. Okay? So nothing new here. Last element we need. Some routes need to be protected. It means it needs to require that the second factor authentication has been performed correctly. How can we enforce this condition? Well, actually, first make sure there is a session. So you have the is logged in middleware in the chain of the route. Okay? Without a session, nothing makes sense. The user has to be authenticated, but it has to it must have performed the second factor authentication. So you need to check also the second factor. And checking it is quite easy, as you can see. Just have a look at session method. Is it equal to TOTP? Yes, it's fine. Okay, we can proceed. Give an answer. Otherwise, it says not authorized. Okay, it's up to you. Just an if. Okay. To be done at the beginning of every callback body in each API that needs a protection. It's the same story as is logged in. If the API needs protection, it means you need to be authenticated. You have the session authentication that is logged in, and then you need to decide if the second factor authentication is required as well. Second one is rec session method equal to TOTP. Okay, and so as we did for the login, and so for the session, then let's say usual authentication, normal authentication, we can make a middleware here as well. It's very simple. Actually, the middleware is just an if. Okay, is TOTP, rec, res, next. If session method TOTP, return next. Otherwise, it says any error message you like. You're missing the TOTP authentication. Okay? You're not missing the actual authentication. You performed the authentication with username and password correctly. It's fine. But to do this operation, we want to have the second factor authentication. So we don't allow you to do that. Okay? So just another entry here in the list of middlewares you have after the URL you want to protect. Okay? So, last slide, then we have a break. So, as you might have seen in these 2 weeks, last week and this week, authentication and authorization are complex problems. Okay? Very complex problems. Try not to invent anything from scratch and try to stick to standardized, well-tested system, mechanism, approaches, and so on. Okay? Try not to invent anything. As I told you, even when you finish your course of study here in cybersecurity, you're probably not able to design anything really secure. Okay? Designing something really secure, well-tested, and so on, it takes a lot of time, years, and it takes a lot of effort, and typically by many, many people. Okay? Because one checks the other and so on. It's not because you are, of course, at the end of the course, you have a good idea of security problems, issues, and so on. But, to make something really secure that can, let's say, withstand the actual usage in production, okay, with the many attackers and issues that comes out every moment, I would say, out in the world, it's really difficult. Okay, so before doing anything, document yourself, study things in depth, and make sure you understand the mechanism. If unsure, try to ask colleagues, experts, and so on, and just use well-tested solutions, not the latest version of last library made by an unknown person somewhere in the internet. Okay? Okay, so that's the end of the story, and we can have a break if you have questions, especially about the exam, but any question is fine. And in the second part, we will implement what we saw here in the slides. So at the end of the lecture, you have a solution of the example with the question and answer, which also implements the TOTP. That's the last big topic required for the exam. Okay? So are there any questions? No? So let's break for 10 minutes. And we will see later how to implement this stuff.